Hi everybody. In this short video we want to look at some square root functions and their graphs. So let's look at this example. F of x is the square root of x cubed minus 11. And this thing under the radical we call the radicand. Alright, so if I'm asked to find f of 2, that of course means that the 2 is going to replace the x up here. So that would be the square root of 2 cubed minus 11. So that'd be the square root of 8. 2 times 2 times 2 is 8. Minus 11. That gives me the square root of negative 3, which is not a real number. Okay, if I were to do f of 3, that'd give me the square root of 3 cubed minus 11. So 3 times 3 times 3 is 27. 27 minus 11, that'd be 16, and the square root of 16 is 4. If I wanted f of 4, that'd be the square root of 4 cubed minus 11. Now 4 times 4 times 4 is 64. 64 minus 11 is 53. Now the square root of 53, that's not going to be, 53 is not a perfect square, so that's not going to equal an integral value, but I can think to myself, well, I know 7 squared would be 49 and 8 squared would be 64, so I know it's going to be somewhere between 7 and 8, and then I can use my calculator to get a decimal value for that. Let's go ahead and do the square root of 53 here. And that ends up being about 7.280109, I think it was. And remember, that's going to be an irrational number, so it's going to go on forever. It'll never terminate, and it will never repeat. Okay? So I might want to just round that off to about 7.28. All right. We also want to look at the graph of a square root function. So let's just plug in some values here to the basic square root of x. And notice that the only x's I can plug in are positive values. All right. And so, in fact, if you just look at this any square root, that radicand, that x in this case, has to be greater than or equal to 0. All right. So the only x's that I can plug in here are going to be, 0 and 1 and 2 and 3 and 4 and so on. So the domain here is just going to be from 0 to infinity, even before I get the graph done. All right, so the square root of 0 is 0. The square root of 1 is 1. Another nice value I could plug in would be 4, right? The square root of 4 is 2, and the next nice value would be 9. The square root of 9 is 3. So let's go ahead and plot those. Here's 0, 0. Here's 1, 1. Here's 4, 2, 5, 6, 7, 8. Here's 9 and up 3. All right, so you can see these lie on. Let's do one more. Let's plug in. How about 1/4? If x was a quarter, the square root of a quarter would be a half. So right here, this would be a half, and so there's x equals quarter, and the y value is a half right there. And so you get a graph that looks something like this. If I can draw it, it's kind of hard with my pen tablet here. Looks something like that. Okay. Anyway, that ends up being the top half, actually, of a horizontal parabola. If you were to graph the bottom half, or just do the mirror image over here, you'd sort of see that makes a parabolic shape, but it's just the top half of that. The range, the only y values you get out of that are also positive or non-negative values, so your range is from 0 to infinity there. Okay? All right, let's do one more problem like that. Suppose I'm asked to find the domain of this function analytically and then verify and find its range graphically. Well, the domain, again, with any square root, or in fact any even root, 4th root, 6th roots would be the same, that radicand, that 3 minus 2x, has to be greater than or equal to 0. You can only take square roots of non-negative numbers. So that means that 3 would be greater than or equal to 2x if I add 2x to both sides, and then just go ahead and divide both sides by 2 here. that would give me that this x on this side is less than or equal to 3/2. Or let's turn it around in English, x is less than or equal to 3/2. All right, so your domain here is going to be from minus infinity up to 3/2. All right, now you can also see that over here. This is the graph of f of x. And if you notice, the graph starts right here at about 1.5, or at least maybe it'd be better to say that's where it ends in terms of the interval notation, but this would be 3/2, right? So the only place where you have graph associated with the x-axis is over here to the left of 3/2. So you can see that the domain works out. Okay? Now, with the range, you might think to yourself, well, what could I get out of this? Well, notice that the square root is always going to give you at least 0, right? In fact, if x was exactly this point 3/2, 3/2 times 2 right here would give you 3, and 3 minus 3 is 0. Square root of 0 is 0. And then if I add 2, I'm going to get at least 2, right? Because the square root's always at least 0, so this will never be a negative number. And if you add 2 to it, you're going to get at least 2. And so I think that if you look here, you can see that the y values are just going to be the ones that are greater than or equal to 2. So the range would be from 2 to infinity in this case. All right? And again, that corresponds to these y values here that have graph paired with them. The only one that's a little bit in question is right over here. Does it include 2? And again, if I let x equal 3/2 right here, you'd see that would give you 0. And square root of 0 plus 2 is 2. So 2 is, in fact, in the range there.